Hello class, these are our notes for 1.8 through 110b. Today we're looking at nth term rule for sequences, but we're looking for when n does not start at 1. So we're not starting with the first term, we're starting with the 0th term. So it's one of those situational things. If you just have a list of numbers, you're probably going to start with term 1, but you might decide you like starting with term 0. But sometimes for the situation you've got, sometimes for the word problem you have, starting at step 0 makes more sense, or term 0. So here we talk about a word problem. In some situations, it makes sense to denote the first term as f of 0 instead of f of 1. For example, if you start your hike at 2,000 feet elevation and gain another 1,000 foot every hour, it makes sense to say f of 0 equals 2,000, as no hours have passed yet, but your starting elevation is already 2,000 feet. And in a graph, the 2,000 feet would be on the y-axis where t equals 0. So it's going to change our definitions a little bit, but not a lot. We're going to look at how it changes. So we're going to look at the specific arithmetic sequence, 5, 8, 11. We're going to look at starting at 1 and starting at 0 and how it changes between the two. So if we're starting at 1, our f of 1 is 5, our f of 2 is 8, our f of 3 is 11. So my sequence is still 5, 8, and 11, but I'm starting it with 1. Recursive. So let's remember, recursive is two parts. We always start with 1. And then we say what f of n is, and we take the previous one, and in this case we're adding, and we're adding 3. And I did not write n minus 1, I just wrote n. So let's fix that really quick. N minus 1 plus 3. And this is for n greater than or equal to 2. So I have this rule up here where n is 1, and then I need to use this rule when n is greater than 2 or 2. So that means for step 2 or for term 2, for term 3, all of those terms. To write an nth term rule, we looked at how that's going to be f of n equals my start, which is 5, kind of like a y-intercept, plus, and then I'm adding 3 each time, and I'm going to add it n minus 1 times. So 3 times n minus 1. This is for n greater than or equal to 1. And we made a point yesterday of pointing out that the n minus 1 is because we start at term 1. All right, now let's look at how it compares to 0. So f of 0 is 5, f of 1 is 8, f of 2 is going to be 11. So it's going to change how we start recursive. Instead of saying what f of 1 is, I want to give the first term on my list, which is now f of 0. So f of 0 is 5. I'm still just adding 3 to my previous term, so the first part of this recursive rule will be the same. F of n equals f of n minus 1 plus 3, but it's no longer for n greater than or equal to 2. I have something for 0 for when n is 0, but after that I need this other rule, this other part to the rule, I should say, so n is greater than or equal to 1. So it's changing just a couple things, right? It changed the beginning, and it changed this part right here. So let's look at how it changes our nth term. So when it changes our nth term, f of n equals 5 plus 3 times, it's just going to be n now. And this is for n greater than or equal to 0. So what I was telling them last hour is you could think about how if we're starting at 0, this would really be n minus 0. And n minus 0 versus n minus 1. Like n minus 0 is just n, right? I can simplify that. And that's kind of something that might be helpful. So the big difference between these two is one of them has 3n minus 1 times the quantity n minus 1. The other one just has a 3n. So now you're going to try. So go ahead and pause and try to write an nth term definition. We are now starting at 0. So go ahead and pause, and then I'll do it. So go ahead and check your, this should be 0. Go ahead and check your nth term rule. Again, we're starting at 5, we're adding 6, so 5 plus 6n, and this is for n greater than or equal to 0. Next, we're going to look at geometric. So first we're starting at 1 again, so 1, 2, 3. For recursive, we give f of 1, and then each one I talk about what's happening to the previous one. So I'm taking the previous one, f of n minus 1, and I'm multiplying by our multiplier each time, by our growth factor. And from 6 to 2, we're dividing by 3, which means we're multiplying by 1/3. and this rule is for n greater than or equal to 1. So if I want the nth term, then what I do is I write f of n equals my start times my growth factor, and the number of times I would multiply it is n minus 1, because we are starting with term 1. And this is for n greater than or equal to 1, because I'm starting with term 1. So again, n minus 1 because we are starting with 1. So when we look at our starting at term 0 or step 0 instead, we have 0, 1, 2. When I start with my recursive, I need to first give f of 0 instead of f of 1. And then this next part's kind of the same. F of n is going to be the previous one, f of n minus 1 times 1/3. But now I'm looking for n greater than or equal to 1, because I have 0 defined, but this needs to be for 1. You know what? This needs to be for 2 over here, doesn't it? Because I already have 1, so this is going to be for 2 and up. So the big differences on these guys again are, again, the first terms that we give. One time the first term is f of 1, the other time it's f of 0, and then the n greater than or equal to 2 versus n greater than or equal to 1. So for nth term, f of n equals, we have our start, 6 times our growth factor, but instead of the power being n minus 1, now it's just going to be n. And again, that's like it's like we had n minus 0, right? Because we're starting with term 0, but the minus 0 doesn't matter. So same thing. And then this is for n greater than or equal to 1 again. Start with term 0. And then we're going to highlight our differences. All right, we've got now a check for understanding. So first they're giving us a definition for a sequence, a rule for a sequence, and it looks like it is in recursive form, and we want to write the nth term of f. And not only is it a recursive term, but it starts with 0 as well. So f of 0 equals 4. 4 is going to be my first term, right? My first term is 0. And then it says 3 times f of n minus 1. That means we are multiplying each previous term by 3, which means our r equals 3. So we're going to write down a definition for the nth term. So f of n equals, we start with 4 times our growth factor, which is 3. And then we're going to raise it to either the n minus 1 or n power. And because we start with 0, it's just going to be the nth power. And this is for n greater than or equal to 0. Did I screw that up here too? Oh my gosh, I did. You can tell it's been a long day. Hopefully I won't make any more mistakes. All right, so, and that's because this one works for 0 on up. We're starting it with 0. So we should highlight that part as well. One more difference. All right, on the next one, we're asked to find, let's see, we have g of 0 is 6, g of 1 is 8. Explain or show how to find the value of g of 12. So right now, our sequence starts at 0, and we have 6, 8. We know it's geometric, so we're doing times 3. That means our r equals 3. So let's go ahead and write out a rule. So f of n equals our start, 6, times our multiplier, which is 3. And because we're starting with 0, it's to the nth power. And this is for n greater than or equal to 0. So if I want to find the 12th term, I'm going to find, and this is actually a g, so I'm going to find g of 12 by doing 6 times 3 to the 12th power. And I honestly have no idea what that is. I'm going to grab a calculator here. That looks a little bit tricky, huh? So let's do 3 to the 12th power. 3 to the 12th. So that's going to be 6 times, let's see, 5, 3, 1, 4, 4, 1. And times 6, 3,188,646. All right, last one. A geometric sequence G starts at 300 and has a growth factor of 0.8. So that means write a graph, sketch a graph showing the first 5 terms. So n and g of n. So my first term is 300. I could call it 0 term also. My second term, I would multiply that one by 0.8. That's going to be 240. Let's see. My third term, I'd have to multiply by 0.8 again. Gonna need that calculator again. So 240 times 0.8 is 192. My fourth term is 153.6. And my fifth term, one more, so I keep multiplying by 0.8, is going to be 122.88. All right, so now I need to go ahead and make a graph. So my x-axis is going to be 1, 2, 3, 4, 5. And then my y-axis, I'm going to count by 300ths. All right, when x is 1, y is 300. When x is 2, y is 240. I'm saying x and y, but it's really n and g of n. We have our input and our output. I found today that it helps students to write down x and y. For my third one, it's 192, so almost 200. My fourth one is about the 150 line and about the 120 line. So you can see this is not a perfect graph. Our goal here is that when we have this growth factor like this, when we have that multiplier, we're seeing like this nice exponential curve. That's our goal here, right? Is that we can just tell that it is not a straight line, that we've got a curve to connect back with things that we know from before in math. So this is the end of our notes for this section. The big idea today, and hopefully I didn't mess it up too much. I know I'm having a tough day. I definitely did not get enough sleep. I want to highlight these guys also as another difference. Hopefully you really understood starting at the 0 term is going to change things just a tiny bit. The n-1 is just changing to an n on those nth term rules. We're changing, it seems like, even less on the recursive. And always, if you need help, please make sure you ask.